What is a photon?
A quantum, or particle, of electromagnetic radiation.
Why does it get so hot when you pour a strong acid in water?
When a strong acid is poured into water, many proton transfer reactions take place very rapidly, and these are exothermic reactions. The fact that these reactions are exothermic means that they release energy, in the form of heat. Increasing the temperature of the solution before the heat has time to dissipate to the surrounding environment.
What is a saturated compound?
A molecule with no pi bonds or ring structures.
What is the inductive effect?
Polarization of a chemical bond due to transmission of charge through other chemical bonds.
What is permafrost?
Permafrost is soil that is below the freezing point of water for 2 consecutive years or more. Most of it is located near the North or South poles or at very high altitudes.
What is osmosis?
The diffusive process of solutes moving from areas of higher concentration to lower concentration.
What is a centrifuge?
A centrifuge is a machine that spins its contents very quickly and is used to separate the components of a mixture. The rapid rotation applies a force that causes the more dense components of a mixture to collect on the bottom of the centrifuge tube and the less dense components to rise toward the top.
How can I make a volcano from vinegar and baking soda?
Chemistry principles encountered in this experiment, chemical reactions, gases, materials you'll need. Vinegar, baking soda, 2 tablespoons, large bowl, baking pan flour, 6 cups, cooking oil, 4 tablespoons. Salt, 2 cups, plastic bottle, dishwashing soap, red or orange food coloring, or any color, really. Water. The procedure. This is a classic chemistry experiment that you might have done before in school. In a large bowl, first mix 6 cups of flour, 2 cups of salt, 4 tablespoons of cooking oil, and 2 cups of water. Mix these ingredients until they are firm. These ingredients are not involved in the chemical reaction that will make your volcano erupt. but rather this mixture will serve as the rock that forms the structure of your volcano. Place the plastic bottle standing vertically in the pan. Use your hands to shape the rock material from the first step into a cone shape around the top of the bottle. Be careful not to cover the top of the bottle. Fill the bottle most of the way with water, leaving enough space to add a few ounces of baking soda and vinegar. Add a few drops of dishwashing soap to the bottle. This is not part of the chemical reaction that will take place inside the bottle, but bubbles from the soap will help to catch the gas evolved during the reaction between the vinegar and baking soda. Add 2 tablespoons of baking soda into the bottle. Finally, slowly or quickly, if you want a really crazy volcano, add vinegar to the bottle, and prepare to witness the eruption. Be careful though, you should avoid getting this mixture in your eyes or anyone else's, and this combination can make a spectacular mess in your kitchen. The chemical reaction takes place between the baking soda, sodium bicarbonate, or NaHCO3, and vinegar. Dilute acetic acid, or CH3CO2H, to release carbon dioxide gas, which is what causes the volcano to erupt. The relevant chemical equation is NaHCO3 plus CH3COOH CH3COONA and CO2 plus H2O.
Why did Ernest Rutherford, United Kingdom, New Zealand, win the Nobel Prize for Chemistry?
For his investigations into the disintegration of the elements and the chemistry of radioactive substances. Rutherford's most famous experiment, the gold foil experiment, was actually done after he received the Nobel Prize. He was awarded the Nobel for discovering that there were multiple kinds of radioactivity. He named them alpha and beta rays. Why did later he added gamma rays to the list? And for proposing that radioactivity was a result of the atom actually breaking apart. Until Rutherford's work, chemists had assumed that atoms were indestructible.
What is iron smelting?
Smelting is a method for extracting a pure metal from an ore. An ore is a rock made up of metals and other minerals. In smelting, a chemical transformation may be used to purify the metal by changing the oxidation state of metals in the ore. We'll get into more detail on what an oxidation state is later in the book. The smelting of iron dates back to ca 1000 BCE, or maybe even earlier. And it typically involves first heating the raw material in a furnace called a bloomery. This produces a soft iron material that can be shaped. A hammer is often used to remove other impurities from the soft metal, before allowing it to harden to form a relatively pure form of iron.
What is substituent?
An atom or group of atoms occupying a designated position in a molecule.
What is quantitative analysis?
Analysis of the specific amounts of the constituent species present in a sample.
What is a dipole?
A molecule or a property of a molecule that involves the separation of positive charge from negative charge.
When did alchemists finally abandon trying to make gold?
In the late 1700s, a scientist named James Price was still hard at work trying to transmute metals into gold and silver. In 1782, he claimed he could convert mercury into silver and gold. At first it appeared that his experiments had worked, but conflict rapidly rose. More and more scientists asked to witness the experiments firsthand. And Price eventually lost confidence in the validity of his own work. After disappearing for a few months, in 1783 he invited scientists to his laboratory to witness his experiments in person, but only a few men showed up. In their presence, Price intentionally ingested a poison, killing himself. He was the last of the modern scientists to claim to have achieved the goals of alchemy. And it is no longer believed that anyone will find a simple way to convert inexpensive metals into gold.
What is a glass transition?
Transition observed in amorphous materials between a hard material and a more liquid or rubber-like state.
What makes carbon monoxide dangerous?
When carbon monoxide is inhaled, it is readily absorbed through the lungs and into the bloodstream where it binds to the phase center in hemoglobin. See also biochemistry. Unfortunately, hemoglobin binds to carbon monoxide much more strongly than it does to oxygen. So carbon monoxide rapidly interferes with the ability of hemoglobin to deliver oxygen throughout your body. If this happens, then your muscles and your brain will begin to run out of oxygen. Similar to what happens when a person is drowning. Carbon monoxide is a colorless, odorless gas, which makes it difficult to detect unless you have a carbon monoxide detector around. Carbon monoxide levels of 100 parts per million or higher can be hazardous or fatal to humans. Poisoning from carbon monoxide can result in brain damage. Damage to the endocrine system, to the nervous system, and to the heart and other organs. It represents the leading cause of accidental poisoning-related death and poisoning-related injury globally. We should mention that even if a person survives carbon monoxide poisoning, there may be long-lasting effects. Early symptoms of carbon monoxide poisoning can include headaches or nausea. And the treatment for carbon monoxide poisoning typically involves having a person breathe 100% O2, recall that air only contains Ca. 20% O2, so that O2 can more competitively bind hemoglobin to replace carbon monoxide.
Peterson, United States, win the Nobel Prize for Chemistry?
For their development and use of molecules with structure-specific interactions of high selectivity. These chemists won the prize for developing/finding molecules that can recognize one another so that they react to form complexes in a highly specific way. They investigated the key features of these molecules that allow for such highly specific molecular recognition. In turn, they produced molecules that can mimic the highly specific recognition features of enzymes. This gave way to the area of research that is today known as host-guest chemistry or supramolecular chemistry.
Will you contract poison ivy if you come into contact with a person who has it?
Poison ivy is caused via an oil called urushiol, found on the leaves of poison ivy plants. The only way to contract poison ivy is to come into contact with this oil. Thus, if a person who has poison ivy still has some of the oil from the plant present on their skin, they could spread that oil to another person. In most cases, though, by the time a person has a rash, the oil will have been washed away. To be clear, the blisters on a person's skin who is suffering from a poison ivy rash do not themselves have the potential to spread poison ivy to other people.
So how little can we detect?
Thankfully, way less than that. Even in the 1990s it was possible to detect lead concentrations as low as 0.1 parts per billion. So analytical chemists are on top of keeping us safe from lead in our drinking water. As long as someone is checking on it regularly.
How does a microscope work?
A microscope is all about lenses. The lens near the sample you're looking at is called the objective lens. And this lens is responsible for collecting the light from the sample and focusing it. Typically there will be a light under or behind the sample that provides the light used to view the sample. At the other end is another lens called the ocular lens, and the total magnification of the microscope is determined by multiplying the magnification of the objective lens by that provided by the ocular lens. The apparatus we typically think of when we think of a microscope is essentially just a big framework used to hold the lenses, the sample, and perhaps other optical devices used to improve the image of the sample.
What is a reaction?
The process of changing chemical bonds in a molecular or ionic compound.
Why are snowflakes unique?
Excellent question. All snowflakes are made up of frozen water, ice, so why don't they look exactly the same? Their unique shape comes from the unique conditions under which each snowflake is made. As a tiny ice crystal is blown into and out of a cloud, or rises or falls in a jet of slightly warmer or colder air, the shape of the growing snowflake can change. In a sense, their shape describes a story of how they were made.
What is scientific notation?
Scientific notation is a commonly used method for expressing large numbers. The number is written as a product of a decimal number and a power of 10. See the following question for an example of where this is useful.
How do OLED screens work, and what are they made of?
OLEDs, organic light-emitting diodes, are a class of LEDs, light-emitting diodes, in which an organic material emits light when an electric current is applied. These can be used to create television screens, computer monitors, cellular phone screens, etc. An OLED may employ either small organic molecules or polymers. One advantage of OLED screens is that they do not need a backlight, which allows them to be thin and lightweight and also to display deeper black image levels than backlit screens.
What is an isotactic polymer?
A polymer in which all substituents are located on the same side of the backbone.
How strong are intermolecular interactions relative to a covalent bond?
Most intermolecular interactions are fairly weak relative to a covalent bond. Covalent bonds typically involve energies on the order of 100 kilocalories per mole. A unit of energy commonly used in chemistry. Van der Waals interactions are the weakest type of intermolecular interaction with typical energies of roughly 0.01 to 1 kilocalories per mole, or 0.01% to 1% the strength of a covalent chemical bond. For a pair of interacting atoms, The strengths of ion-ion and ion dipole interactions can vary widely. Particularly in solutions, because the ions and/or dipoles can be separated by very different distances. The charges of ions can also be significantly shielded by solvent molecules around them. If the ions are very close together, like in a solid, their interaction energy can approach, or even exceed, that of a covalent bond. Hydrogen bonds are usually the strongest type of intermolecular interaction with energies of about 2 to 5 kilocalories per mole, or roughly 2% to 5% the strength of a covalent bond. Because they are such strong interactions, hydrogen bonds can play a dominant role in determining the structures of liquids, solids, and single molecules.
What is accuracy?
Accuracy is used to refer to how close a measured value is to the true value of the quantity. This is pretty simple to understand. For example, if the true temperature in the room is 20 degrees Celsius and a thermometer reads 20 degrees Celsius, the measurement is pretty accurate. If the thermometer read 0 degrees Celsius, the measurement is not very accurate.
What is process accuracy?
Closeness of a measurement to the actual or accepted value.
Where are electron transfer reactions important?
Electron transfer reactions are important in many areas. In biological systems, processes like photosynthesis, nitrogen fixation, and aerobic respiration. The process your body uses to make energy using oxygen, all rely heavily on electron transfer reactions. Electron transfer reactions are also frequently used to obtain pure metals from ore. Electrochemical cells, see analytical chemistry, also rely on electron transfer reactions. The batteries that power your cellular phone and other devices use electron transfer reactions to do so.
What is emulsion?
Non-superimposable mirror images.
What do the numbers on the periodic table mean?
The periodic table lists elements in boxes containing their name, atomic number, chemical symbol, and atomic mass, averaged over the natural abundances of the various isotopes.
What is the collision frequency?
Average number of collision events per second.
What is a lattice?
A regular array of atoms or ions.
What is an atomic mass unit?
One atomic mass unit has a mass of 1.66 x 10 to 27 kilograms, which is about the mass of a single proton or neutron. These units are convenient, since when the mass of atoms is expressed in atomic mass units, their masses come out to values that are very close to integers. The values of mass given on the periodic table are expressed in atomic mass units.
What is an oxidation/reduction reaction?
Oxidation and reduction reactions are chemical processes that involve the transfer of an electron between two species. Oxidation is the process of taking an electron away from a species. So if a molecule loses an electron, it has been oxidized. Reduction is the process of giving an additional electron to a species. So if a molecule gains an electron, it has been reduced. Oxidation and reduction reactions are particularly important in the field of electrochemistry.
What is a supercritical fluid?
Above its critical point, a given temperature and pressure combination. A substance behaves like both a liquid and a gas and is called supercritical. Supercritical fluids are very good solvents, like liquids. And as a result many modern chemical processes use them.
What is chromatography?
Chromatography is a method for separating chemical compounds based on chemical properties as they travel over a distance. The sample to be separated may be in a solution or in the gas phase.
What is an RNA?
Ribonucleic acid, composed of a chain of nucleotides, encodes genetic information.
How is rainfall affected by pollutants in the atmosphere?
Air pollution can affect local and global weather patterns, including the amount and frequency of rainfall. At low concentrations, particles floating around in the atmosphere may help clouds and thunderstorms to develop. But as their concentration increases, these same particles can Inhibit the formation of clouds that give rise to rainfall and thunderstorms. This topic is also relevant to issues surrounding climate change. Since clouds are understood to generally have a cooling effect on the climate because they reflect incoming sunlight.
Why did Richard R. Ernst, Switzerland, win the Nobel Prize for Chemistry?
For his contributions to the development of the methodology of high-resolution nuclear magnetic resonance, NMR, spectroscopy. Nuclear magnetic resonance, NMR. Spectroscopy has proven to be a powerful tool for physical and synthetic chemists alike. It has been used to characterize the structures of simple organic complexes, complex biomolecules, and to dynamically track the progress of chemical reactions, among other applications. Ernst won the prize for his substantial contributions to increasing the sensitivity and resolution of NMR instruments. Ernst contributed to improving a wide variety of aspects of NMR spectroscopy, including both ONI and two-dimensional approaches. And he also proposed a method for obtaining NMR tomographic images, which was eventually realized.
Who first proposed the idea of elements?
Plato is often given this accolade as he was the first to use this term for his description of the 5 basic shapes that he believed made up the entire universe: tetrahedrons, icosahedrons, dodecahedrons, octahedrons, and cubes. He went on to ascribe each shape to a basic element, borrowing from Empedocles. See next question. The tetrahedron was fire, icosahedron, water, dodecahedron, ether, octahedron, air, cube, earth. While this association of basic geometrical shapes to the nature of the universe obviously didn't work out for him, Plato's ideas did lead Euclid to invent geometry.
What is an electron?
Fundamental particle with a negative electric charge.
How are compounds separated by distillation?
Distillation is a purification technique that involves using the different boiling points of compounds to effect their separation. As a solution containing a mixture of chemicals is heated, the compound with the lowest boiling point will evaporate first, and this can be collected on a cool surface after it has diffused away from the solution. In this way, a pure liquid component can be isolated from a mixture of liquids.
What is a microwave?
Electromagnetic radiation with wavelengths of 1 mm to 1 meter. Just longer than infrared radiation, but not as long as radio waves.
How is recycled plastic used to make fleece?
Fleece can be made from polyethylene terephthalate, PET, bottles. The first step is to wash and then mechanically crush the bottles, shaping the plastic into small chips. The chips can then be heated and forced through tiny holes in a metal plate, called a spinneret, which forms fibers that harden as they cool to room temperature. These fibers are wound onto a spool as they are formed, and they can subsequently be stretched to improve their strength. Machines can then be used to texturize and cut the fibers to their desired length and be used to make fleece cloth for clothing, blankets, etc.
What is a s orbital?
An atomic orbital with an angular momentum quantum number of 0, shaped like a sphere.
What is a phase diagram?
A phase diagram shows the phases of a particular substance as a function of temperature and pressure. An example for a single component phase diagram, as in not a mixture, is shown above. Phase diagrams also exist for mixtures, but these get very complicated very quickly.
What is the freezing point depression?
Decrease in freezing point for a solution from that of a pure solvent.
What is a chemical signaling molecule?
Chemical signaling molecules are small molecules that act to carry a message in a biological system. A cell can secrete signaling molecules and allow them to diffuse through the bloodstream. Signaling molecules can also be stuck to the surfaces of cells. It would be impossible to give a comprehensive description, so we'll just mention a couple of examples of chemical signaling. Apoptosis, which is the intentional death of a cell, is a process that involves chemical signaling. An external signal reaches the cell, which sets off a series of reactions inside the cell, ultimately leading to its death. Calcium ions are another species often involved in cell signaling, as their concentration affects the activity of many proteins and is also important for telling cells when to reproduce. Hormones are another type of chemical signals. They travel through our bodies, controlling growth of muscles and tissue, our reproductive systems, and our metabolism, among other things. These examples are just a small sample of the huge number of processes controlled by chemical signaling.
What is experimental error?
Experimental error describes the uncertainty or variation in a measurement that is repeated several times. This variation could come from many sources, such as limitations in the quality of the device being used to make the measurement, the ability of the experimenter to accurately repeat the experiment or measurement, or something intrinsic about the quantity being measured.
What is ortho?
Term used to describe two substituents on an aromatic ring that are bonded to adjacent positions.
Which energy sources produce the most CO2?
By far, it's the fossil fuels, oil, gas, and coal. It's the CO2 from all those combustion reactions that makes up about 96.5% of all the carbon dioxide emissions.
What is paramagnetic?
A molecule with no net spin. A material that is only attracted in the presence of an external magnetic field.
What is the Nernst equation?
The Nernst equation relates the reduction potential of an electrochemical cell to a standard state reduction potential, along with the temperature, reaction quotient, and number of electrons transferred during the reaction in question. It was first developed by Walther Nernst, who won the Nobel Prize in Chemistry in 1920 for his influential work in physical chemistry.
What does immiscible mean?
Unmixable liquids, e.g., oil and water.
Why did Rudolf A. Marcus, United States, win the Nobel Prize for Chemistry?
For his contributions to the theory of electron transfer reactions in chemical systems. Marcus received the prize for his work studying electron transfer reactions and developing the theory surrounding this elementary chemical process. The transfer of an electron between two molecules is a ubiquitous process in chemistry, and it is important to a wide range of chemical phenomenon, ranging from the conduction properties of materials to chemical synthesis, to the capture of light by plants for the purpose of harvesting energy. Marcus completed much of the work surrounding the theory of electron transfer in the 1950s and 1960s. And he was able to explain the greatly varying rates of electron transfer observed in different chemical systems. Some aspects of his theories were difficult to confirm experimentally, and were not proven until the 1980s. Which contributed to why it took so long for him to receive the Nobel Prize for his work.
What is a base?
A compound that accepts hydrogen ions, Brønsted-Lowry acid. Has a pair of available electrons, Lewis, or releases hydroxide ions in solution, Arrhenius.
What is a heteroatom?
A heteroatom is any atom that is not a carbon or hydrogen atom. Some examples of typical heteroatoms include oxygen, sulfur, nitrogen, phosphorus, chlorine, bromine, and iodine, though anything other than carbon or hydrogen fits the definition.
Why did William S. Knowles, United States, and Ryojin Wayuri, Japan, win the Nobel Prize for Chemistry?
For their work on chirally catalyzed hydrogenation reactions and K. Barry Sharpless, United States, for his work on chirally catalyzed oxidation reactions. Half of this prize was awarded to Knowles and Noyori for their work with chiral catalysts that chirally catalyzed hydrogenation reactions, or reactions in which two hydrogen atoms are added. This work found applications in pharmaceutical production soon after its discovery. Sharpless was awarded the other half of this prize for developing chiral catalysts to carry out oxidation reactions, which represent another important class of reactions in organic synthesis.
What is an element?
Atoms with the same atomic number.
What is splenda, R?
Splenda, R, is a commercial name for an artificial sweetener, like NutraSweet, R, or equal, R. Sucralose is the key sweet ingredient in Splenda, R, but unlike natural sugar molecules, sucralose is not metabolized, so it effectively has 0 calories. It's made from regular table sugar by selectively exchanging 3 O groups for chlorine atoms.
What is Gibbs free energy?
Gibbs free energy is a quantity that describes the amount of useful work. See physical and theoretical chemistry, that can be obtained from a system at a constant temperature and pressure. In the context of chemical reactions, changes in Gibbs free energy will typically dictate whether or not a reaction is favorable.
What about cis and trans fats?
The carbon-carbon double bonds along the hydrocarbon chain of fatty acids can be either the cis or trans isomers. Naturally occurring unsaturated fats have more cis fats, while man-made fats, like margarine, have a higher level of trans fats. Trans unsaturated fats turn out to be particularly bad for humans as they increase cholesterol, leading to heart disease.
How is biodiesel produced?
The production of biodiesel fuel involves a chemical reaction called transesterification of lipids. Those from the vegetable oil or fat, with alcohols to produce alkyl esters. Methanol is most commonly used as the alcohol in these reactions, which leads to methyl esters, though other alcohols have also been used. Glycerol is a byproduct of the transesterification reaction, and this compound is actually formed in fairly substantial quantities, ca 10% by mass. This has given rise to research directed toward finding ways to carry out chemical reactions beginning with, or involving, glycerol, such that the cost efficiency of the overall process of biodiesel production might be improved.
What is polarity and how is it related to molecular structure?
Polarity is related to the symmetry of the arrangement of electron density in a molecule. Polar molecules are those which possess a net dipole moment, which means that the electron density is not symmetrically distributed in all directions. Nonpolar molecules have the electron density distributed in such a way that there is no net dipole moment. Typically, this doesn't mean that nonpolar molecules have their electron density distributed evenly over every part of the molecule, but rather that the dipole moments created by an unequal sharing of electrons in each individual bond cancel each other out, so that there is no net direction in which an asymmetry of electron density exists.
How fast does light travel?
In a vacuum, the speed of light is about 3 × 108 meters per second, which is very fast. That's so fast that a beam of light could travel around the whole world in only about 0.13 seconds. It's interesting to consider just how far away from the Earth stars really are. After the Sun, the next closest star to the Earth is over 4 light-years away. A light-year is the distance light travels in 1 year. This means the next closest star is over 20 trillion miles away. Because light must reach our eyes for us to see anything, if that star exploded, we wouldn't see it until over 4 years after it actually happened.
What is a de Broglie wavelength?
Also known as matter wavelength. Inversely proportional to the momentum of the object or particle, see also wave-particle duality.
Why did Richard Adolf Zsigmondy, Germany/Hungary, win the Nobel Prize for Chemistry?
For his demonstration of the heterogeneous nature of colloid solutions and for the methods he used. Although the Nobel Committee didn't mention it by name, the methods he used refers to Zsigmondy's invention of the ultramicroscope, which allowed a visible light microscope to see objects that are smaller than the wavelength of light. Zsigmondy accomplished this, literally, physically impossible task by looking at the light that's scattered off of a sample, and not the light that it reflects. Using this new tool, he showed that the red color in so-called cranberry glass was due to small 4 nanometers, particles of gold, which was of interest to his employer at the time, shot glass.
What is an actactic polymer?
A polymer in which the chiral centers are arranged randomly along the chain.
What is the difference between heterogeneous catalysis and homogeneous catalysis?
Homogeneous catalysis takes place when the catalyst and the other reactants are all dissolved in the same solution. Heterogeneous catalysis typically involves the use of a catalyst that is insoluble, or perhaps only weakly soluble, in the solution in which the reaction takes place. Thus, in heterogeneous catalysis, the catalyst and solution may form a suspension, or the catalyst may simply be a solid that is placed in the solution.
What is ductile?
Pliable, not brittle, a metal that can be drawn into a thin wire.
What is diffraction?
Change in the direction of a wave caused by an obstacle, be it a wall, or a nucleus.
If cooking spray is just oil, then how can it have 0 calories and no fat?
Cooking spray lets you apply a thinner layer of oil than you could probably achieve by pouring normal liquid vegetable oil out of a bottle. The FDA states that any food substance with less than 5 calories and less than 0.5 g of fat per serving can be labeled calorie-free and fat-free, respectively. So manufacturers of cooking spray adjust the recommended serving size to contain less than those limits. As a result, your can of spray contains hundreds of servings. Go check your pantry if you don't believe it.
Where does coal come from?
Coal is formed from trees and plants that died hundreds of millions of years ago. The dead plant material eventually became buried deep underground, which placed a large amount of pressure on it. Over time the plant material became compressed and hardened, eventually forming coal. While this resource can be replaced over very long periods of time, we use it much faster than it can ever be regenerated.
What are some common units of concentration for a species in solution?
The most common unit of concentration in solution phase chemistry is molarity, or the number of moles of a species present per liter of solution. Recall that the number of moles of a species is equal to the number of molecules of that species divided by Avogadro's number. See History of Chemistry for information on Avogadro's number. In analytical chemistry, it can often be more convenient to discuss concentrations in terms of other units. This is particularly true when the species being studied is present in very small concentrations. Some other commonly used units are parts per million, ppm, parts per billion, or parts per trillion. These units refer to the mass fraction of the analyte in question to total mass of the sample. 1 part per million means 1 millionth, 10 to 6, of a gram of the species in question. Or analyte, per gram of the sample present. Similarly, 1 part per billion means 1 billionth, 10 to 9, of a gram of analyte per gram of sample. And 1 part per trillion means 1 trillionth, 10 to 12, of a gram of analyte per gram of sample. It is also possible to use each of these definitions based on a per unit volume basis, rather than a per unit mass basis, though this is more common in the gas phase. For example, 1 ppm by volume of an analyte means the analyte occupies 1 millionth, 10 to 6, of the total volume of a sample.
What is a pK?
The logarithm of an acid dissociation constant.
Is a calorie in food the same as the unit of energy used by scientists?
The calories listed on food labels are actually kilocalories when converted to standard units for energy. So if the package for your snack says it contains 100 calories, that's really 100,000 calories in the units of energy used by scientists.
What is the activation energy?
Difference in energy between the reactants and transition state. Or activated complete, for a chemical reaction or process.
What is normality?
Concentration of a solution defined as the molar concentration divided by an equivalence factor. I.e., H2SO4 can neutralize two equivalents of base with its two H end groups. So a 1m solution of H2SO4 is 2n, the equivalence factor of H2SO4 is 0.5.
How can I suck an egg into a bottle?
Chemistry principles encountered in this experiment: combustion pressure, ideal gas laws, materials you'll need. Hard-boiled egg bottle or flask with an opening slightly smaller than the egg's diameter, paper. A sheet of computer paper or newspaper will do, matches the procedure. Note: this experiment involves fire and flammable materials, so adult supervision is a must. Peel the hard-boiled egg. Tear off a piece of paper that can easily fit into the bottle. And carefully light it on fire and drop it into the bottle. Quickly place the egg on top of the bottle, covering the opening. The flame will burn, heating the air inside the bottle. This causes the air to expand, and some of it will push past the egg to escape from the bottle. Recall from our discussion of the ideal gas law that, for a fixed number of particles and volume, the pressure inside the bottle should increase linearly with increases in temperature. The increased pressure is what pushes the air out. And you may even see the egg shake a little as the air escapes. Then the egg will come to rest, covering the opening. Eventually, the fire will burn up all of the paper, or all of the oxygen inside the bottle. Whichever comes first, and then the air in the bottle will begin to cool. As it cools, the volume it occupies will decrease, lowering the pressure inside the bottle relative to that outside the bottle. The higher pressure outside the bottle is what pushes the egg through the opening and into the bottle. You can get the egg back out by tilting the bottle upside down and blowing air into the bottle, and then allowing the egg to cover the opening before removing your mouth. Thus you can use the same principle regarding equilibration between high and low pressures to force the egg out.
How many cells are there in your body?
An adult human is made up of approximately 50 trillion cells.
How do you measure the pH of a solution?
One of the first ways science students usually learn to test the pH of a solution is by using pH paper. This is a pretty simple test that only requires you to place a drop of the solution onto the paper and to look at its color. The color change accompanying changes in pH is due to a chemical indicator whose absorption spectrum changes with changes in pH. Another way to measure pH is with a pH-sensitive electrode. This can provide a more accurate measure of pH, as it digitally outputs the pH as a number value and does not rely on a person visually inspecting a color change to interpret the result.
What is a liquid?
A state of matter with a defined volume, but no fixed shape.
Why do metals make for such effective active sites in enzyme catalysis?
Metals are crucial components in enzymatic catalysis for largely the same reasons that organometallic complexes make good catalysts. These include the fact that many metal centers can complex to a variety of substrates, undergo facile changes in oxidation state, and provide good electron donors or acceptors. These characteristics can, and often do, work together to accomplish some remarkable chemical feats.
What's special or different about organic foods?
While the precise definition is still changing, everyone agrees that organic foods are those grown without the use of pesticides or synthetic fertilizers. The organic label also frequently excludes the use of irradiation and genetically modified fruits and vegetables. Whether the food tastes better, or is healthier to eat, is for you, or at least someone other than us, to say.
Why did Frédéric Joliot, France, and Irene Curie, France, win the Nobel Prize for Chemistry?
For their synthesis of new radioactive elements. Frédéric was an assistant of Marie Curie, who ended up marrying Marie's daughter, Irene. The husband and wife team of Joliot and Curie collaborated on experiments, investigated the effect of bombarding atoms with other particles. Specifically, they struck boron, magnesium, and aluminum atoms with alpha particles. He2+ ions, creating new short-lived radioactive particles.
What is a sugar?
Sugars are part of a class of biomolecules called carbohydrates that are made up of carbon, hydrogen, and oxygen atoms. The simplest sugars are called monosaccharides. But, like amino acids, they can polymerize to form disaccharides and oligosaccharides. Sugars can usually exist in either a ring form or an open chain form, as shown in the picture below. The sugar in this picture is called glucose, which is the sugar most commonly used for energy in the human body.
What makes leaves change color in the fall?
Leaves are normally green because of chlorophyll. Chlorophyll absorbs blue and red wavelengths of light, so it appears green. This molecule is crucial for photosynthesis, but when the days begin to get shorter as winter approaches, plants begin to produce less chlorophyll. As the level of this green chemical in leaves falls, we can start to see other highly colored molecules. In particular, carotenoids, which appear yellow, orange, or brown, start to become visible. These molecules are always present in the leaves. It's just that the green color of chlorophyll dominates most of the year.
What is Avogadro's constant?
Avogadro's constant is a large number used to discuss large quantities of atoms or molecules. Usually when chemists talk about quantities they can actually see or measure out. The number itself, rounded at 3 decimal places, is 6.022 x 1023. It's just a big number. That relates an atomic or molecular mass to the mass of a collection of many atoms or molecules. Avogadro's number of atoms of an element is called a mole of that element, and similarly, Avogadro's number of molecules of a compound is a mole of that compound. For example, the atomic mass of oxygen is about 16 grams per mole, and 6.022 x 1023 atoms, 1 mole. Of oxygen weigh, s, about 16 grams. The most recent, and accurate, definition of this constant was 6.0221407.8, 18. X 1023, which was calculated by careful measurements of the mass and volume of 1 kilogram, about 2.2 pounds. Spheres of silicon 28, a particular isotope of silicon, see next chapter concerning isotopes.
How do modern chemists characterize the products of chemical reactions?
Chemists need to characterize the products of their chemical reactions so that they can be sure of the structure and composition of the molecule, they have made. One common way is by measuring the melting point of a solid substance. This doesn't provide specific information about the arrangement of chemical bonds in a molecule, though, so more advanced techniques are required to completely characterize a molecule. These techniques often involve using electromagnetic radiation to probe the energy levels in the molecules. See Physical and Theoretical Chemistry for more on these topics. Knowledge of what energies/wavelengths of light the molecule can absorb can be related directly to structural features of the molecule.
What is enthalpy?
For a reaction, the heat absorbed or released is defined as the change in enthalpy.
What were some early models for the atom?
Experiments suggested that atoms were actually made up of smaller particles, which motivated the development of new models involving protons, neutrons, and electrons. One was Thomson's plum pudding model, which described the atom as a positively charged pudding filled with negatively charged electrons. Rutherford later proposed the idea of a positively charged nucleus, but couldn't explain why electrons didn't just fall into it. A Danish physicist named Niels Bohr proposed the idea that electrons travel around the nucleus in specific orbits and advanced the atomic theory to a point very close to where it is today.
How does hand sanitizer work?
The active ingredient in hand sanitizer is usually an alcohol like isopropanol. This chemical is also used in antiseptic wipes and pads. Because of its ability to kill bacteria, fungi, and viruses.
What is a carbocation and what is a carbanion?
A carbocation is a positively charged compound in which a carbon atom takes on a significant fraction of the positive charge. The definition for a carbanion is probably easy to guess. Then it's a negatively charged compound in which a carbon atom bears a significant fraction of the negative charge.
What causes dandruff?
Despite what you may have heard, dandruff is actually not caused by dry skin but rather by a specific type of fungus or yeast. While dandruff does cause flaky scales of skin to shed off of the top of a person's head, dandruff is actually due to the interplay between yeast organisms and natural oil glands. Unfortunately, there is no genuine cure for dandruff, but it can be controlled by using special shampoos containing zinc pyrithione, selenium sulfide, coal tar, or ketoconazole. To be effective, these products typically need to remain on the skin for several minutes before being washed away. In fact, the scalp is not the only place that dandruff can occur. Dandruff can also manifest on a person's eyebrows, mustache, and beard area, as well as the ears and the nose.